everybody. Please find a seat. Again, we're pretty packed on seating, so if there's a seat in the center of your row, just if everyone can shift down and make sure that that there's lots of that there's seats available for everyone, because we really just have enough seats for everyone attending the summit. Thank you very much. Great. So how's everybody doing? Nice. Lunch was good. Green Goddess. Woohoo! We're psyched for them. And thank you so much for doing all the work around the composting and bussing your plates and stuff. That's a huge help for us. So just a couple remarks before we get started on this afternoon sessions. Just a reminder on the interactives. I didn't mention the photo booth that's set up by Clarence the Moose. I don't know if anybody's seen that yet, in the Find Out Forest behind the glacier. I love giving directions in the Wild Center. It's by the moose in the Find Out Forest behind the glacier. So please take some time to go out and get a photo. Dress up and do something silly. That would be great. We have a lot of really great sessions this afternoon, starting with the plenary in here. Then we'll move directly into our next round of workshops. We have a lot of great workshops. Again, five workshops this afternoon, a very short break, and then another 5 workshops, and then our final plenary session that starts in here right after that last session. So you're just going to be going. So make sure as you're coming back here in the afternoon for that final plenary at 4:45 to grab a jacket, because we are going to be going outside. It's beautiful out right now, but it'll probably cool off when the sun goes down. Okay, so I'm going to ask Erin to come up and introduce our next speaker. Thanks, Erin.
Susan E. Powers received her PhD in environmental engineering from the University of Michigan in 1992. The research that Dr. Powers and her students complete includes life cycle assessments on fuels and energy sources and their overall environmental impacts. Her research on energy education has resulted in the development of an energy literacy survey and an award-winning 8th grade energy systems unit in science or technology classrooms. Her work integrating research and education over a wide range of educational levels contributed towards her receipt of the National Science Foundation's Director's Award for Distinguished Teaching Scholar. This is the NSF's most prestigious award in this area. Let's give a round of applause to Susan Powers.
Good afternoon, and so it's my second chance to talk to some of you. I'm a last-minute fill-in on this topic, but hopefully you still understand what's going on. So I know when many people think about climate change, and we've actually proven this in surveys, that people in New York State, you're concerned about what? You're concerned about the polar bears and the polar ice cap, right? We're concerned about islands in the Pacific that are going to get sea level rise is going to flood them out. Most of the time, though, people in this region don't think climate change is going to affect them. Or if it does affect them, it's not going to be for decades and decades. And so it's really important to think about our climate has already changed, even in New York State. And maybe some of the impacts that we face are a little less drastic than what the rest of the world is going to face, but they're still important. And so my job here is to talk about the climate of your future, if you stay in New York State, and just what is that going to look like. And so I am going to be looking just a little bit about where our climate is today and recent changes, but mostly what the climate's going to look like when you're my age, and then even, when your kids are my age, so out into the future to about the year 2100. And in order to accomplish that, I first need to talk a little bit about climate change modeling and how we model those predictions so you have some sense of how do we even think about what the climate's going to look like back then. So you've heard a lot about human activities this morning from the ACE presentation, people in my workshop, we talked about energy and energy activities. So human activities have a lot to do with climate change. We are what's causing a lot of the carbon emissions and nitrous oxide and other greenhouse gas emissions. Because of those emissions, the carbon dioxide concentrations in the atmosphere are changing. So what did it reach last April? A big round number? 400 ppm, and what are we looking for? 350. Okay, you know your ppms, great. So, but it's because we are putting carbon dioxide into the atmosphere that we have those high concentrations. But then the net result is that the climate is changing. And all of these things are interconnected. But we have to really understand these causes and effects in order to predict what is the climate going to look like over the next century. And it gets a little more complex. I say here, climate changes. But first and foremost, we think about temperature changes. And of course, we know temperature is going up. But that's also causing changes in our water cycle. How much rain we get, it's causing changes in agriculture, our ecosystems, and eventually, as you heard this morning some from the ACE talk, problems like air quality and asthma and human health and social impacts as well. So they're all connected to temperature, but they're also all connected to each other. The water cycle is affecting ecosystems in agriculture and humans. The ecosystem changes are affecting agriculture and certainly our social systems. And we really have to think about all these interconnections and all of these causes and effects to be able to model and predict what's happening in the future. So let's start with temperature changes. So historically, this is in the northeast part of the United States, not just New York State, or some of it's New York State. Annual temperatures, or the annual average temperature in New York State has changed almost 2 degrees Fahrenheit compared to the late 1900s. So like 1960 to 1990. So 2 degrees Fahrenheit, that's a little bit more than 1 degree Celsius. So that's a fair amount. Winter temperatures, though, have increased even more. So about 5 degrees Fahrenheit, so closer to 3 degrees Celsius. And there are about two days per year more where it's really hot, like temperature greater than 90 degrees Fahrenheit. So is that good or bad? Me as a gardener, I'm happy. I can have my tomatoes this fall all turned ripe and the tomato plants were done before we had a frost, right? So in some senses this is good, but at the same time it means our ecosystems are changing and fundamentally all the interdependence and interconnections are different. And if we want to predict what happens in the future, this is historical, then we really have to think about it. So here's a great resource. Where's my... Do I have a pointer on here? I didn't ask. Which button is the pointer? That. All right, I tried that. All right. I'm not going to make the pointer work. All right, so this is Tupper Lake, New York. You can find historical data for any weather station in the world at this Goddard Institute of Space Science NASA website. So this is Tupper Lake. The red is summer and the blue is winter. And so this is over more than 100 years. Really, the historical records for temperature thermometers, so our modern thermometer was really built in 1880. And so we have good historical temperature records directly from thermometers back to about 1880. So this temperature record goes back to the late 1800s. And it shows that the temperatures, so those are just linear regressions, it shows that the temperatures increased. And if you look at the slope of the line, those slopes, linear regression, are really important. If you look over 100 years, in Tupper Lake, the temperature in the summer has increased a little over 1 degree Celsius, so that's 1.8 degrees Fahrenheit in the summer, but 1.7 degrees Celsius in the winter. And so that's, I can't do that in my head, about 3 degrees Fahrenheit warmer now than 100 years ago. So on average, Tupper Lake is changing more than the New York State average. And you can, by using this website, you can, oh, there it goes. You can find any. Canton's got a good one. There's lots of good websites there, or weather stations that you can get access to. So the temperature truly is changing. But again, that's historical. If we want to predict what's going on in the future, we want to eventually predict precipitation, temperature, sea level rise. We need a climate change model. Most of us think about the earth science part of that model, right? How much radiation is coming from the sun, how much is reflecting, but permafrost melting, sea level changes, ocean currents, that's all the earth science data. What we don't really think about, though, is the human and the social science data has to also go into that model. And so we're not going to be able to predict climate in New York State over the rest of the century without understanding the human side and human activities. So there's a huge amount of climate science and climate modeling that's social science. that's not earth science, and it's really, really important. It turns out this is where the biggest uncertainties are. We don't know how humans are going to behave for the rest of the century. And so what's our population going to be? Are we going to be global in nature or very localized and nationalistic in nature? Are we going to switch to renewable energies, or are we going to continue with fossil fuel energies? All of those sort of human activities and human inputs are a really important part of predicting our climate future, and we really just don't know. So the scientists, all these social scientists, have come up with various stories about what our future looks like. And these are used internationally, so they cover economic growth, population, technology development, whether or not we communicate across the globe, or we develop renewable technologies and we don't share them with developing countries, whether or not we're committed to the environment or just committed to, consumerism. All of that's part of the stories. And there are different stories that come up with sort of our best case and our worst case. And so our best case stories have lower emissions, lower carbon dioxide emissions, fewer people, less consumerism. And the higher emissions, or the worst case, are continued reliance on fossil fuels and a lot of emissions throughout the century. And there's a lot more to the science. But I'm going to keep talking about this sort of best case and worst case, depending upon how we choose to live over the next century. And so here is sort of our primary energy used. So this is the energy that we consume, and this is globally. And so this is the worst case, the blue, and the green is the best case. And these are the, you don't need to worry about the details. So the worst case shows that we're going to use, these are exajoules, so 10 to the 21st joules, up over 1,500 exajoules per year by 2100. The best case is the green line, and we're about 750 exajoules by 2100. And right now we're under 500. So in all cases it's showing, mostly because our population is expected to grow a lot, we're going to be using a lot more energy. But the graph on the right shows us how we're going to use that energy. So in this worst case, the black is coal. Significantly more coal, some solar, some renewables and non-fossil based, but mostly fossil based. The best case here still is a lot more than the year 2000, twice as much coal, less oil, twice as much natural gas, but also a lot more of the non-carbon intensive energy systems. So these are the different stories. These are the different stories ranging from our best case to our worst case, and I'm only going to rely on those two. But in all cases, it's more coal than we use today, because we'll have a lot more people in the future. So now we know our emissions. That's sort of the range of human activities that showed us what we're going to what our energy future is going to look like in the future. And so the next step is to go from our human activities to what are the concentrations of the atmosphere going to look like. And so remember our two numbers before, we said 400 and 350. Look at this, over 900 parts per million carbon dioxide in the atmosphere in the worst case. Best case, we're still over 400. And it will continue to go up some more as we transition to renewables, but then it'll come down some. Remember, that's where our 350 is. So that's what we think is safe. So right now in our stories, even our best case doesn't meet our 350 target. All right, and then the final is, what are the climate changes? So here's a couple of pictures globally about temperature changes. And this is the best case. So if you look at our scale here, so this is degrees Kelvin, but this is a change in temperature. So these are anomalies or differences from now. And this is winter, January. And so it looks like the polar places are changing the most. They're going to be up about 8 degrees Celsius hotter by 21, or the end of the century, 30 years at the end of the century than today. It's sort of hard to make out New York State. This is a global scale. We'll be down somewhere in here, the 2 to 3 degree temperature change. So that's the best case. Let's look at the worst case. Ooh, more red, more orange. So we might be up closer to 3 or 4 degrees, but the Arctic up closer to 10 degrees. So that's what our models predict at the global scale. Our job now is to take that global scale model and scale it down so we can look at our region in much more detail. We want to know what's going to happen to the Adirondacks or the Lake Champlain region, St. Lawrence Valley region. And so work has been done to scale that down regionally, and this was done largely by a group, the Union of Concerned Scientists. So temperature changes. We've already seen how the temperature changes. This is what the future looks like. And again, I've got these two models, the higher and the lower emissions. So we're looking at up to, by 2100, up to about 10 degrees Fahrenheit hotter than the average 1961 to 90. These are temperature change from this range here, where it was pretty constant, and at least, about 5 degrees Fahrenheit. So if you've guessed how old I am, you're talking about, when you're my age, we're looking at least 4 degrees Fahrenheit warmer in New York State, or northeast United States compared to before. And so what does that look like? This is a great graphic that was done. So compared to when I was growing up, that's what New York State looked like. Right now, we're entering this period where it's like Pennsylvania used to be when I was growing up. And by the time you're my age, New York State is going to look like Tennessee or South Carolina. So have any of you traveled there in the summer? How does it feel? Pretty hot, not like what we're used to. What about winters? Are they skiing? No. So this is a great graphic, and then when your children are growing up, it might be more like Georgia or Virginia. So this is sort of the best case and worst case. It's clearly going to, in either, even in the best case, it's going to be a lot warmer. So that's what New York State's going to look like. We talked about extreme temperatures this morning and some of the difficulties with asthma. Extreme temperatures, people die, in part because of respiratory problems, in part just because of heat stroke. And so this is New York City, which is part of New York State. So these are temperature, how many days per year over 90 degrees? We're talking 40 to 70 degrees. That's most of the summer. In New York City, it'll be over 90 degrees. And between 7 to 25 days, it will be over 100 degrees by the end of the century in New York City. It's truly temperatures at which people die. So clearly some human health and social implications there. All right, so now that's the temperature change. We know temperature is going to change a lot. That's going to affect the water cycle. We've got changes in snow, precipitation, and extreme storms. This is precipitation. This actually doesn't look that bad. So by the end of the century, or even maybe 5 to 10% more rain than we have now. It doesn't sound bad, right? So it's not that horrible until you look at the nature of that rain. It's all going to come down. So we're going to have, this graph is a ratio. So one is, we're at 1. So we're at 1 right now. So 50%, this means that it will be 50% more days with rain more than 2 inches. What does 2 inches look like in a rainstorm? It's a lot of water. And so we're going to have 50% more days, 50 to 75% more days that we have a lot of 2-inch rainstorms. And our 5 days in a row, we'll have about 20% of the 5-day totals will be warm. So it's not that much more rain over the year, but it's going to come in more intense storms. And you know the result. This is a photo from Irene. So this was from Essex County someplace, I don't remember. So we're going to get more intense storms that cause a lot of damage. A lot of social implications, a lot of ecosystem implications. So it definitely is an important thing. So you can't just look at the percent change in precipitation, but the nature of those rainstorms. And a big thing around here is snow. And the temperature is going to be different in the winter, and the nature of the precipitation events are going to be different in the winter. And this is how most of us spend our winters, right? We like snow. I'd rather have snow than cold, freezing rain, because we like to be outside and play in it. So the red line on this picture is the average from 1961 to 1990 of the area that had at least 30 days with at least a little bit of snow on the ground. And so almost all of Pennsylvania, certainly all of New York State except for Long Island, had at least 30 days of every winter with, at least some snow on the ground. When you look at the predictions for 2100, or actually the 30 years leading up to 2100, well, the high peaks are still going to be okay. But, this is only an inch. This is not feet. Tug Hill, maybe a little bit on the south end of Tug Hill, but southern New Hampshire, I grew up about here, it was always snowy there. St. Lawrence County, not 30 days of snow in St. Lawrence County. So big changes in the face of winter in the future. And so that has an impact on the economy. So our ski areas might be ATV parks instead of ski areas. Who knows what the winter will look like? So this graphic on the left shows higher emissions for, this is the 30 years that we're currently in. So there's Whiteface, that might be Stowe, I don't know what ski areas, maybe Stratton in southern New Hampshire. So these are ski areas, and if they're green, it means there's a high probability that they'll be in good shape. If it's green and red, that means that they're vulnerable, that they might not be able to survive, and if they're red, forget it, they're not going to be ski areas anymore in an economic sense. So when we go to when you're my age, even Whiteface and Stowe, you might not be skiing there when you're my age. So there's still Stratton, I don't know what's down here. Northern Maine, still okay. But by the end of the century, you know, very few ski areas in the Northeast will still be ski areas. So might not be worth teaching your kids to ski. And it's economically viable. They could still make snow on some days, but it'll be very different in the economy and our social system. And of course, there's a sea level rise. So the graph on the left shows global mean sea level rise. It's going to be somewhere around 1/2 meter, or about, you know, a yard, somewhere in here. And if we put that in inches, you know, 8 inches to a yard higher than now. So you might think that's not that bad. And in most days, it's not that bad. But a high sea level rise coupled with an intense storm, that's when it gets really dangerous. And so that's when we have things going over sea level. And to come back to New York City, in our state, is where the damages are going to be seen the most, New York City and Long Island. And so this is a mathematical projection. And the idea is that right now we have 100-year storms. And Superstorm Sandy was more than a 100-year event. But it used to be a 100-year weather event happened, the probability was that would happen once every 100 years. What used to be a 100-year event is now going to be the new 10-year event. And so those sorts of storms are going to happen every 10 year. And you can see this is the southern tip of Manhattan. I'm not doing well with this. So this is the southern tip of Manhattan, and where it's blue inside this zone is going to be underwater. So a lot of southern Manhattan is going to be underwater every 10 years by the end of the century. But of course, it's already happening. This is a picture from Superstorm Sandy. These areas are already underwater, and that might happen now every 10 years. And so even, you know, we've got the storm, sea level is a little higher, but during storms, it goes way high. So that's it for the hydrology. If we look at the ecosystems, how temperature changes ecosystems, a big thing is the timing of the seasons. I already said I can grow tomatoes much better now than I could 20 years ago when I planted my garden. Flowers are blooming earlier, lilacs 4 days, grapes 6 days earlier. One of the big problems with this is the pollinators. Bees might not be in the right spot at the right time. Our apple trees might not be pollinated because the bees are not evolving as fast as the change in the budding process in our ecosystems. Maple is a big deal in this region. So if you look at the yellow area of this map, that's where maple trees grow. So this is our current situation. If you look at, so this is, again, 2100 and our best case scenario. So we still have maple trees in most of our areas. Some areas of Lake Ontario, southern New Hampshire, Massachusetts is going to lose a lot of its maple products. But if we look at the higher emission, or the worst case, if we still use fossil fuels for the next century, maybe the Adirondacks can still produce maple syrup. St. Lawrence County, Jefferson County, Lewis County, we're going to produce a lot of maple syrup. That's going to be gone because the maple trees just cannot grow in the warmer climate. So some species will be at benefits, like deer. We already have deer overpopulation. They will benefit because snow will be less deep. They can get to forage. Plants will be greener for a longer season. They'll be better. That fish is a bass. Bass are a warm water species, they'll thrive, but at the same time, our brook trout won't. Moose are already, we're barely into moose range, they will suffer. And snowshoe rabbits, they're turning white before the ground is turning white. And now a perfect prey. No camouflage there. And so some species are at risk. Unfortunately, the things that are going to thrive the best are the pests. Fleas, I don't know if you've noticed on your dogs and cats, fleas are worse. This picture over on the right is kudzu. And I talked to some students the other day, they haven't, this is, if you go to Georgia, you see kudzu grows fast. It's a vine. It was brought over to put on steep slopes to prevent erosion. Well, now it's a very, very invasive pest. And corn earworms. I'll get back to kudzu. So our pests will thrive with the climate change. Here's a pest that we're concerned with, the Hemlock woolly Adelgid. It grows on hemlock plants. You might think it's mold, but it's really a pest. It sucks the moisture out, and so leaves die, and here's dead hemlock trees. We have a lot of hemlocks in the North Country. And there's a cascading effect here. So the hemlocks often grow near brooks where brook trout are. They die. That means more sunlight gets to the water. The water gets warmer. Our brook trout will not thrive. Our fisher people will not be happy. And if you look at the income from trout anglers in all of these dark areas, over $1 million a year in expenditures in these regions for trout. And so it's going to, again, coming back to the human impacts with the economy because of the brook trout. All right, and I'll close up here with some comments on agriculture. A lot of dairy farms, a lot of apples are really important. The water cycle changes as well as the temperature changes will change our agriculture. So if we look just at apples, this map shows us regions where most of our good apple varieties grow. So the whole North Country, and so this is current, and this is the worst case scenario. If we look at the next 30 years, you can see apples. We won't be able to grow apples very well in the western part of New York State. And by the time we get to the end of the century, most of the state will not be great for apples, just the region in the North Country. The green areas, so including some of Jefferson and Lewis County, 50% of the years won't be good for apples. And so it's a huge part of our agricultural economy, and a lot of small farms are apple growers, and so that will be threatened. And that's because apples need something called chill hours. They need it to be cold in the winter, and they need it to not be too hot in the summer. And so if we look at, we might be looking like Virginia by the time you are my age. We're going to have to switch to Empire and Delicious apples. I'll tell you, I love Cortland's. I hate Delicious apples. I would be really, really sad if we have to grow Delicious apples. They shine up nice and shiny, but that's about the only benefit. So we'll have to change our apple grows. And dairy. So cows also don't like it hot in the summer. If it's too hot, they do not produce milk. And so the yellow areas and green areas are good for dairy. So this is our worst case, this is our best case, and over the current 30 years, middle of the century and end of the century. And you can see worst case, end of the century, Jefferson and Lewis, St. Lawrence County, there's a lot of dairy farms. They are not going to be productive for dairy farms in the worst case, might still be okay in the best case. So our dairy farms, so agriculture is going to change tremendously. And remember that kudzu. I always thought this was a Georgia and Alabama thing. So the red areas are the areas where kudzu will grow. These are all worst case. So in the next, if it gets here, and it'll come, it's going to be most of New York State by, even before you're my age. By the time you're my age, it's going to be up to about the Thruway, and the Adirondacks will be free of kudzu, but I've got to move my car more often than I do now because it's going to be covered with kudzu if I don't worry. So just the nature of that pest, it's hard to imagine kudzu. And it's an invasive species.
It's been found in Albany.
It's been found in Albany. Yeah, okay, so it's coming. But there's some benefits. So this is grapes. Grapes like it not too cold. Remember, apples like the cold. Grapes like it not too cold. So this is in Geneva, New York, which is in the Finger Lakes. In 1950, there were about 20 wineries there. Now there are 300 wineries in the Finger Lakes because it does not get as cold. And so if it gets below minus 10 degrees Fahrenheit, then the buds are killed, and below 15 degrees Fahrenheit, the vines are killed. And if you look at the last 2 decades, only a few years have the grape people worried. And so even now, wineries are growing in this region too, and it's because of climate change. So there's some trade-offs there with agriculture. So from an agricultural perspective, we're going to need to change the crops that we grow. There'll be some things that we can grow that we haven't been able to grow, but weeds and pests are going to grow too, and so we have to accommodate them. So we might be able to do better with watermelons and grapes, but we got to look out for the floods, the kudzu, and the cornworm. So just to wrap up here, climate change has impacted us already. Even though you might think it's only those people on the Pacific Islands who are going to get inundated by sea level rise, or if you think it's only the polar bears and people in Alaska, it is happening here, and it will continue to impact how you live in New York State. Hopefully not life-threatening, but it will change our economy, our agriculture, and our ecosystems over the next century. Thank you.
Thank you, Dr. Powers. Well, I feel like, knowledge is power. So, between Brian this morning and Susan giving us a very good grounding in the climate science, it was just so fantastic because I feel like now, being able to say when someone says, well, what's happening in New York? Well, I can think of 5 things off the top of my head after watching Dr. Powers talk that I can say. One of the other threads I've seen throughout our plenary sessions and also with some of the workshops I've been to today is that idea of story and how being able to tell the story of climate change and how it affects you personally, how it affects your school, how it's affecting your community is really, really powerful. And so I just keep coming back to that idea. We've got a lot of work to do, but I'm excited that we're all here doing it. So this next session, check out the workshops we have. We've got some great ones. I want to give a shout out. We have Kristen Ferguson, who's here from Denver. She, I think, maybe traveled the farthest. From the U.S. Green Buildings Council, she'll be here doing a workshop on story of self. Brother Youssef and Paul High will be in the Naturalist Cabinet, using the power of nature to transform youth. That's go to the glacier, make a left. Sifting through science, that's in Planet Adirondack with some Wild Center staff. That's go to the glacier and make a right. That's that big globe thing. It's super cool. Cutting your school's carbon footprint, that's with Casella, and Green Tour with one of our Wild Center staff. That's in the Find Out for Us. And then another garden workshop that's going to be in the Wild Supply Company. Please go directly to your workshops, divide and conquer, and have a great afternoon.